So this assignment is related to topic polarization. And again, it is a very important topic. You will find in the past paper, you will find many questions related to the topic. So in the first question, it is sometimes difficult for a fisherman to see the fish due to the glare, as you can see here, which is caused by the reflection of a sunlight from the surface of the water, and using the use of the polarizing sunglasses can help to reduce the effect of a glare as shown in the second photograph. So basically what happened, the light which is reflected from the surface of the water enter the eye, and some of the light which passes through refracted or and then bounce back of the fishes, that is also coming out. So we are getting both components of the light. That's why we don't see clearly, but as a result of a polarizing sunglasses, what it appear that the reflection part is removed, so we'll see the fishes which are under water. Describe what is meant by the polarization of a wave. So you have to write the definition. So how we define the term polarization? So the term polarization refers to the wave, like polarized wave is a wave which is having oscillation or vibration in one direction. That is one thing, because it's of 2 mark definition. So polarized wave has an oscillation or vibration in one direction, that is 1 mark. And these vibration are perpendicular to direction of the wave. So we can write a polarized wave is having oscillation or vibration in one direction, which is perpendicular to direction of wave. So the wave in which the wave is moving, that direction is perpendicular. Example, it's in a 3D. If we draw, so the vibrations are perpendicular. So vibrations are in the same plane, but they are perpendicular to direction of wave, because you can see vibration is either up or down and the direction of wave is towards the right. So we call that as polarized wave. Or you can also say the polarized wave has oscillation or vibration in one plane, and that is which include, if we mention the plane, because there are two things. If you only mention a vibration direction, like if you simply mention a polarized wave is having an oscillation or vibration in one direction, so oscillation and vibration in one direction and that are perpendicular to direction of the wave, that is one way to explain. Or if you mention a polarized wave is having a vibration or oscillation in one plane, like when we mention plane, it means we mention the axis, the region, and which include the direction of the wave travel, that will also give you the mark. Like this is one plane, and this plane also include, like this whole is a one plane, and this plane also include the direction of the wave travel. So this is a second definition, but I prefer that you write the first one, because it is easy to recognize that oscillation or vibrations are there in which the direction is perpendicular. The second, explain why the fish look darker when viewed through a polarizing glasses. What is the reason why it appear to be darker when we are looking using a polarizing glasses? So what they will do, these sunglasses or polarizing glasses, they will absorb the light which is perpendicular to the polarizing like plane of the sunglasses, and sunglasses only transmit or allow the oscillation which is parallel to the plane, which reduce the light intensity. Or we can also say that these glasses or sunglasses block the light which is perpendicular to the plane of the glass, which reduce the intensity, like amount of light. That's why it appeared to be darker. So again, it's of 2 mark. Why there are 2 mark? 1 mark is for mentioning that the plane of the sunglasses, like example, if I say this is representing a sunglass and it's having a regular arrangement of the particles, so they say this is a alignment of the particles, a horizontal. But the light which is coming out after reflecting from the surface, that is having both component, like vertical component is there and horizontal component. So as a result, what happened? The sunglasses only allow the horizontal component to pass, the component which is parallel to the plane of the sunglasses can pass, and one which is vertical or perpendicular. In this example, the perpendicular won't pass through. That's why when it is passes through this glass, it will appear to be, because this is more component of the light, so this will be bright. This is always the case whenever we observe a light through a polarizing sunglasses, it will always appear to be dim because it does not have many component, it has only one component. So why the fish look darker when viewed through a polarizing glasses? Is because the glasses block the light which is perpendicular to the plane, and that reduces the intensity. That's why it appear to be darker. Is it clear? The second part, part B. The diagram shows two polarizing filters A and B, which could be used in sunglasses. The arrow represent the plane of the polarization of light transmitted through the filter. Like B will allow the horizontal component of the light and A will allow the vertical component of a light to pass. The fisherman is viewing the fish that are underwater through a polarizing glasses. The light which is reflected from a surface of the water is partially polarized in a plane parallel to the surface. So which filter, A or B, the fisherman should use in the sunglasses in order to see the fish clearly? So if we draw this, like example, this is the surface of the water. As I mentioned, the light which bounce off the plane of this, like as you can see, they mention that the fishermen want to see the fishes which are underwater through a polarizing sunglasses. The light which is reflected from a surface of the water is partially polarized, mean like it is having other component, but in plane parallel to the surface of the water. So what does it means? Like major component, say this is a light which is coming out from the sun, which is unpolarized light having multiple component, but when it reflects, most of the component are like horizontal, greater proportion is there for horizontal component. There are other component, but horizontal component is major. That's why, and they mention that the component which is parallel to the surface is coming out as in this part, that the light reflected from the surface of a water is partially polarized in a plane parallel to So this is a parallel to the surface. Then which the when the light travel, the light, because it will refract, and say this is a shoal of the fish. So when it bounce back, it will also have component. So these are the components which are there. So what we want to reduce the reflection. We don't want to see the reflection from the surface. We want to reduce the reflection. So example, if I use B, because the question is which polarizing filter should be used, A or B. So if I use B, then what happened? Because the B allow the horizontal component to pass, so B will allow the reflection to pass, so it won't reduce the reflection. We want to reduce the reflection, so which polarizing filter glasses we should use? We should use A, because when we are using A, only the vertical components will be able to pass through and the horizontal component will be completely blocked. So means the reflection from the surface will be blocked. So explain which filter, A or B, the fisherman should use. So he should use A. And what is the reason for that? Because for filter A, its plane of the filter is perpendicular to the component of a light which is reflected, so it will block the light. Or light from the fish is unpolarized, so still it can be seen. So A we will write, and the reason is because it will block the reflection of light, as the plane of the filter or polarizing filter, you can use polarizer, filter, analyzer. These are the terms used for filter. So because it will block the reflection, as the plane of this filter is perpendicular to reflected light. So that's how a fisherman is able to block the reflection. Another question: some solutions rotate the plane polarized light. So basically, what is the concept? Some solutions have the tendency, they, instead of allow certain component to pass, they rotate the polarized light. So if we pass a polarized light, the rotation can happen, means the light emitted out in another component, it remain polarized, both are polarized, but what happened, the component is changed, rotated, and it can rotate clockwise or it can rotate anti-clockwise. Normally sugar solutions, they have different capability. Higher concentration of a sugar solution means greater capability to block to rotate the polarized light. So some solutions rotate the plane polarized light. The degree of rotation depends on the concentration of solution. Like if you have more particles, then it will have a greater tendency to rotate the polarized light. Polarimeter are devices that determine the concentration of a solution by measuring how much the plane polarized light is rotated. So using a polarimeter, we can identify how much plane polarized light is rotated, and using the concept of how much rotation is there, we can use a graph, like we can sketch a graph between concentration and rotation, and we can any unknown, work out the concentration of unknown solution. So example, if we have angle, if we have theta or angle here, and the concentration of solution, high concentration solution means cause the light to rotate more. Low concentration solution will cause the light will rotate small amount. So if we increase the concentration, the rotation, the angle of rotation is also increasing. So Using this graph, we can work out any unknown concentration, just place a sample and we identify how much it causes a rotation to the polarized light, and we can find the unknown concentration of X. But the first part, describe what is meant by a plane of polarization of polarized light. So plane of polarization of polarized light, what is the definition of this? So polarized light which is having an oscillation in a single plane, and that is the plane of polarization that include the direction of propagation. Look, in the previous, what is the difference between this question? What is the difference between this first part in question 2a, plane of the polarization, and polarized wave? So you should be writing the definition correctly, because when we say polarized wave, what does it mean? It means like this is a direction in which the wave is traveling and its vibration are perpendicular. A vibration are 90 degrees. So it is moving up and down, and the wave is traveling towards the right hand side. So in which the vibration are perpendicular or oscillation are perpendicular, we call that as a polarized light. But what is the meaning of plane of the polarized light? The plane of the polarized light means the wave in which oscillations are there in the plane, like in region, if you're looking, for example, from the top, this is you're looking from the top. So this whole is refers to a plane. So this plane in the wave is oscillating in the plane, and that plane include the direction of the wave as well. That region include the direction of the wave. So whenever you're defining plane of the polarized light, what should be your wording? The definition should be correct. So the polarized light that has oscillation in a single plane, like in one plane it is oscillating, and that is a plane of polarization. So the oscillation or vibration in one plane which include the direction of propagation. So when you mention oscillation or vibration in one plane, you will get the 1 mark, and include the direction of the wave. When you refer a plane of the polarized light, don't use the term perpendicular. If you use the term perpendicular, it means like two are in different ways. So oscillation or vibration in one plane or one axis, and that, like that whole propagation, that whole region include the direction of the wave. Is it clear, the definition of plane polarization of polarized light? So two things are very important. Students get confused when they see the term polarization of light. They just simply write the definition, but it depends on whether they're asking plane of the polarization or they're only asking polarized wave. The diagram represents the part of a polarimeter. Like this is a polarimeter. We have a light source, then a polarizer is there. Here we'll place a sample, and then there's an analyzer. In an experiment, determine the concentration of solution. The following steps are used. The polarimeter is set to make with no solution. So in the beginning, there is no solution present. The light from the source is polarized by the polarizer. Like example, the source is emitting out unpolarized light, light which is having multiple component. But when it passes through the polarizer, it is, example, horizontal or vertically polarized. And because if nothing is placed here, so when the analyzer and polarizer having a same axis, same plane, so the light will able to pass through. So the analyzer is rotated until the light from a source is no longer has been seen. Like in the beginning, we will see the light from the source and we will rotate this analyzer. Like if I draw the planes, so these are the planes originally, because it is vertical, so I should draw vertical. So this was vertical originally, and this is also vertical. But when we rotate until the plane of the analyzer is perpendicular or 90-degree to the light which is coming in, then what happens? There will be no light, because it will block that light, does not allow that light to pass through. So the analyzer rotates until the light from a source is no longer seen. Now the solution is placed in the tube between the polarizer and analyzer. So then what we do? We place a solution here, a sugar solution or any solution which we are finding the concentration. Then the solution is placed in a tube between the polarizer and analyzer, and this whole glass tube is containing a solution, but I just drew as a beaker so that you understand the fact, but otherwise whole glass tube is having a solution. The analyzer rotate until the light from the source is seen again. Source is again no longer seen. So what will happen? We place the solution, because when we place the solution, this will cause the rotation of the light. As it causes the rotation of the light, we'll able to see some light. And then again we rotate this analyzer until there will no light. No light means that the plane of the filter is perpendicular to the component of the light. The angle through which the analyzer rotates after placing a solution between the filter is measured. Explain why light from source can no longer be seen in step 2. So why we are not able to see, like example, we have unpolarized light from the source, nothing is placed, but we are not able to see any light. So what is the reason for that? Why there is no light in step 2 when the polarized analyzer is rotated? So what is the reason? It means the plane of the analyzer is perpendicular or 90-degree to the light. So light is completely absorbed and no component, like if we draw the plane, so this plane of the analyzer and the component of the light, they are perpendicular, so it absorb all light and the angle between them is 90. That's why there is no light able to pass through this analyzer. So when you write the answer for this part, you will mention that the analyzer is rotated a 90-degree to the polarizer, or the angle difference between the analyzer, the polarizer and analyzer is 90. So the light is absorbed and no light is able to pass through. Explain why making measurement on a particular solution, the angle measured in step 5 is, when making a measurement on a particular solution, the angle measured is 55. Explain why the plane of the polarization of light may have been rotated by more than 55 and suggest another possible angle. So in this question, what is happening when we are making a measurement, the angle which the light is rotated, that is 55. Like example, we place a sugar solution or a solution here. So when the solution is placed, the light which is passing through the polarizing filter, that is uh, polarized, but when it passes through the solution, it rotates the light. And how much the angle change in angle is there? That can be, that is in the question, that is measured to be 55. It rotated the angle 55, because, and how we identify, because when we rotate the analyzer angle 55, then we are not able to see any light again. So because originally there was no light, then we place the solution, we are getting a light, and then we rotate the analyzer, again there is no light. So when we rotate the analyzer 55 degrees, we are getting no light again. So it means the plane of the analyzer is now exactly perpendicular to the light which is coming out from the solution. So what could be the possible angles? Because after every 90-degree rotation you don't see any light. So suitable angles, what we can say, if the polarized light is rotated, so at 55, we are getting no light. It means the plane is perpendicular. Like this is a symbol for perpendicular. It means the plane of the analyzer and the light both are perpendicular. Then if we rotate 90 degree, 55 plus 90, so it will be 145. So when it is 145, there will be light. Because what will happen? That time the plane of the analyzer and the light will be parallel. Then we further rotate again 90, because after every 90-degree change, like there will be light, no light, light, no light. So originally at 55 there is no light. So 55, if we change the angle by 90, there will be light again. Then after 90, it means at 45 there will be light again. But if I change further 90, so this will be how much? This will be 235. So when again it is changed by angle 90, there will be no light again. And it means the plane are again perpendicular to the polarizing filter. Then we further rotate 90. So this will be how much? 235 plus 90, so 325. And 325, what we'll get? We will get a light again. Because again, what happened? The plane turned out to be parallel. If we further change 90, then 425, 325 plus 90, so it will be 415. So 415, again it will be perpendicular, so no light again. So if at 55 there is no light, then at 235 there will be no light, at 415 there will be no light. Because after 90-degree rotation, there will be light. After further 90-degree or total 180-degree rotation, there will be no light again. So when we write the answer here, as they're asking why the plane of the polarization of a light may have rotated by more than 55 and suggest another possible angle of rotation. So what might be a reason? Because the solution concentration, because the rotation depends on the concentration of solution. High concentration solution rotate the light more, and if the light is rotated, it can be rotated by 180. So the plane of the polarization will remain same again, and the value it can be 235 or 415. Is it clear discussion? Any doubt in this part? So always remember, whenever so possible angle 235 or 415 will be there, as it will turn back to dark or no light again. So every 90-degree rotation leads to light, no light. Experiment produce the same result if the filter were arranged, give a maximum intensity in step 2 and 4. Suggest the advantage of rotating the analyzer until no light is seen. Like they're giving you an idea that we can also do this same experiment. Like here, how we started the experiment, as you can see, first we were having an unpolarized light. Using a polarizing filter, we polarized the light. We are getting a light first, but we did not start the experiment. We started the experiment first by rotating the analyzer. We rotate this analyzer by 90 degree. Once the analyzer is rotated 90 degree, there is no light. And when we have no light, that moment we fill up this a glass tube with a solution, and then we are observing a light, and then we rotate it further until no light again, and we measure that angle. So they're saying why this is an advantage. Even it can be done in this manner, that we started, if we start the experiment, we are able to see the light. We can just place a solution here, a sugar solution, and when we place this sugar solution, because we know the light will rotate, so light intensity will decrease, and we will further rotate until we'll see the light again. But we are not doing in this manner. We are doing, for first we are not getting any light, we place a solution, and then we again rotate the analyzer until no more light is there. So what is, how it can, why it is useful? Because look what happened. It is easy to identify when no light is there rather than minimum or maximum light. Because what happened, example, you started the experiment, the polarizing, passing it the light vertically, and the analyzer is passing it vertically. Then you start the experiment, you're able to see the light. You place a sugar solution or any solution which you are finding a concentration. That solution will cause a light to be like rotate the polarized light. So you have to rotate the analyzer again. You have to rotate the analyzer until you will see the light again. But the problem is, it is difficult to identify like intensity of the light, even like at what moment we are getting the same intensity. So it is difficult to identify the minimum and the maximum intensity of the light. If there is no light directly, if it is completely dark, we can identify that no light is there. For when it is completely dark, there is no like minimum dark or maximum dark. But when there is light is coming out, there is a minimum light and maximum light. Even some of the light is able to pass through. So it will be difficult to recognize the minimum and the maximum light intensity when it is coming out. So the chance of error is there, that a human error, that we might not able to identify. Maybe we think this is the same amount of light which is coming out without the solution, but maybe it was not. That's why we are not doing the experiment when we see the light. We are doing the experiment when we don't observe any light. So why it is an advantage of using, why state advantage of rotating analyzer until no light is there? Because when it will be difficult to identify minimum and maximum light intensity compared to no light. So there will be greater percentage uncertainty or error if experiment started with light. seen through the, or light passing through the analyzer. Is it clear, this experiment? Then Iceland spar is a crystalline form of calcite. An incident light is unpolarized light into two plane polarized rays by a sample of ice spar. The two rays polarized light follow a different path. What is the difference between polarized and unpolarized light? So this is also a common question, the difference between polarized and unpolarized. So you will mention unpolarized light is having many vibrations or many direction of vibration. Polarized light will have only single oscillation or vibration, single direction oscillation. And oscillations are perpendicular to direction of propagation. So why it is of 3 mark? You will mention unpolarized light, multiple oscillation, directions, and polarized is having single oscillation or vibration. And because when we mention the direction of oscillation, so what should be the third mark? That the direction of the oscillation is perpendicular to direction of propagation. That is for both of them. Or there is also a second definition, because some student write definition in terms of planes. So unpolarized light is having many planes, and polarized light is having a single plane, and that single plane include the direction of propagation. So when either you mention plane or you mention, but when you are using a term plane for a polarized light, you should mention that the plane include the direction of propagation. So it's better you use the term oscillation or vibration rather than plane. Otherwise, you will be confused. Then the photograph shows how the separate path of a light produce two images of object behind the sample. As you can see, when a polarizing filter is placed on the sample as shown, only one image is seen. Explain why only one image is seen and describe how would you use a filter. How sorry Explain why only one image is seen and describe what would be seen as the filter is rotated 360. We'll continue this question, less than a minute left. I'll share another link.